Hey, good morning, pre-calculus students. Sorry if I'm speaking low. Nobody's awake yet. So this is a video to help you with your corrections on test 12. Thank you for taking the test honestly. I was really pleased with how many people were honest. It must have been tempting to do the wrong thing. So thank you. As a reward, we're going to give you points back on some of your corrections. I think we're still deciding it's a third or half of the points back. But either way, you're going to make corrections. The instructions on Google Classroom read something like this. I want you to erase from your mistake on down and do your correction in ink so I know what's old and what's new and you have work or room to work with, okay? So hopefully you have an eraser out and an ink pen and you know what you've missed because you were able to open the test in Google Classroom. Look for the return test and click the three-dot icon, and I think you can see the commented on test. All right. If not, then let me know, and I'll be checking my email today, and we'll troubleshoot it. All right. So now to the math. Number one, this is the probability of or, and so a visual helps. Remember, if you want the probability of two things happening in either or, then I could say, what's the probability of a 3 happening if I draw a Venn diagram? What's the probability of a heart happening? Or both. So when I want the probability of 3 or hearts, then you first find the probability of 3, which would be all that. And then you find the probability of hearts, which would be all that. But the problem is, you see in the video or in the picture, is that we've now double counted the overlap. And so we're going to remove the probability of 3 and hearts. Not because we don't want to count it, but because we don't want to count it twice. All right. So if you then find each of those probabilities, the probability of 3, there are 4 3s in a deck of 52 cards. As far as hearts goes, there's 13 hearts out of 52 cards, and 3 and hearts, or how many 3 of hearts are there is, well, that's 1 out of 52. That should get you going. 17 minus 1 50 seconds is 16 50 seconds. And that reduces to 4/13. All right. So hopefully that makes sense. I'm going to pause for a second and move the sheet down. Okay. First of all, I hope you saw my correction online that this is supposed to be x plus 3z equals 5. Otherwise, you could combine like terms, get 4x equals 5, x is 5/4, and that's kind of a dumb question to solve for x because it doesn't take any Cramer's rule at all. So it should be x plus 3z equals 5, all right? So setting up Cramer's, I hope that you know the denominator is the matrix of the coefficients. So the x's are 3, 1, -1. Check your first column. The y's are -2, 0, 2. And the z's are 0, 3, -5. All right. So first thing you do is check your column. As you know, hopefully in Cramer's, then the top matrix, what you're looking for gets replaced. And so because we're looking for x, we're going to replace x with 0, 5, and -7, the constants, on the right-hand side of the equation. The z stays the same. Sorry, the y stays the same and the z stays the same. All right, so again, check your top. Although I got to say, I didn't see many mistakes on people setting up wrong. It was pretty much all calculation errors. So it's up to you whether you do cofactors or the extra 2-column method. I saw more people have success with the extra 2-column method, so I'm going to do that way. All right. And I'll come to the bottom in a second. But remember, when you do the two-column method, you multiply down to the right, down to the right, down to the right, and then subtract up to the right, up to the right, up to the right. All right, so when I multiply down to the right, I get 0, negative 2 times 3 times negative 7 is negative 6 times negative 7, so plus 42. And then 0 times 5 times 2 is 0. Minus up to the right. Negative 7 times 0 is 0. 2 times negative 5 times 0 is 0. And negative 5 times negative 2 is negative 25 times negative 2 is positive 50. So in the top you should get 42 minus 50, or negative 8. All right. Now let's talk the bottom. The bottom, again, copy the first two columns, 3, 1, negative 1, negative 2, 0, 2. And here we go. Down to the right is 3, 0, negative 5, which is 0. Negative 2, 3, 1. I missed, sorry. Negative 2, 3, negative 1, which is positive 6. Don't lose negatives. That is one of the biggest sources of error. And 0, 1, 2 is 0. Now up to the right. Negative 1 times 0 is 0. 2 times 3 is 18. And negative 5 times 1 times negative 2 is 10. So I get 6 minus 28. Just checking my work. 6 minus 28 is negative 22. Negative 8 over negative 22 is 4/11. Now I will say this. If you did not do it that method, it doesn't matter what method you used, these two results should be the same. So your top matrix should have been negative 8, and your bottom matrix determinant should have been negative 22, and then it reduces, okay? Okay, so matrix multiplication, I was pleased with how this went. It's not easy, a lot of places to make a mistake, and usually there are two types of mistake. One is just a small calculation error, and then one is people weren't sure what the answer should look like. They had the right numbers, but not the right places. All right. So remember, the idea is that you name a matrix by rows and columns. So there are 1, 2, 3 rows, then 2 columns, and then this is 2 by 2. Now, because these inside match, it is possible to multiply them, and your answer is a 3 by 2. Now, that's 3 rows by 2 columns. Okay. So your answer should look like that, not a long horizontal matrix. And you might have had the wrong things in the wrong places. All right, so now we're going to multiply. Here we go. When we multiply, we're going to take a row times a column and multiply and add. So I'm going to take 2 times 1 and 0 times 2. That's 2 plus 0, so that's 2. I multiplied the first row times the first column, and that's where the answer goes, the first row, the first column. Now when I go to multiply the first row times the second column, I'll take 2 times 3, which is 6, plus 0 times negative 5, which is 0, that's 6. Where does that go? Well, that was first row, second column, so that's where it goes, first row, second column. 6. Continue that. Now let's go to the second row and multiply. Second row is 2 times negative 3 times the first column is 2 minus 6. 2 times 1 plus negative 3 times 2 is 2, and negative 6, that's negative 4. Now we're going to multiply the second row times the second column. 2 times 3 and negative 3 times negative 5 is 6 plus 15, that's 21. And last, third row times first column. So we have 4 times 1 and 1 times 2. What's that? I hope you said 6. And 4 times 1 times the second column. 4 times 3 and 1 times negative 5 is 12 minus 5, or 7. There's your answers. That's what hopefully it looked like. Okay, 2a minus b is subtraction. And if you're trying to subtract, it's totally different than addition. When you add or subtract, you add things in like places. Well, if these are different dimensions, then what do you do with this third row? There is no third row over here. Well, that's just not possible. To add or subtract, they must be the same dimensions. So if you tried, then you are set up for failure, because it is not possible to add or subtract matrices that are different dimensions. There doesn't have to be like a row of this match a column of that, like multiplication. They have to be the same. They have to be the same in every way, same rows, same columns. And so that's not possible. Okay, for 4, I was happy with how many people did this well. If we have another test, maybe you'll see a fraction base, and that's a little different, but this went well. So there's 2 components to this. The first is the solution, and the second is the domain. I can start by saying, well, I want to get what x is, so I want to get rid of log base 4. And whatever I do to one side, I do to the other. So hopefully you exponentiated first. Remember that it matters whether this base is more than 1 or less than 1. If the base is between 0 and 1, you flip the inequality, but if it's not, you don't. So this is strictly x minus 2 is less than 16. If you add 2, then x is less than 18. Now that said, why is the other part even necessary? Well, x less than 18 would mean you could use negative 100. Well, you can't use negative 100 in there. You can't take the log of a negative. That's like saying 4 to what power is negative 102. Well, that's not possible. So you have to have also this domain component to keep from breaking math. X also must be greater than 2 to keep from taking a log of a negative or trying to find a positive number to a power that makes it negative, which is not possible. So x has to be between 2 and 18. Anything in that range works. Anything outside that range either breaks math or doesn't make the problem true. And last but not least on this page, number 5, the binomial theorem to find the 8th term. Binomial theorem implies that you're using this factorial idea to find the coefficients, which is handy, especially in large-scale cases. You don't want to do a Pascal's triangle if the power is huge, like the 12th. That's a ridiculous waste of your time. So you need to know this. Remember, the best place to start is this guy's power. The second term power usually starts at 0 and works up. So by the time they want the 8th term, this would be to the 7th power. The next place you go is that the powers of these two have to add to the total power. So if they have to add to 12, and this power we found is 7, then this power must be 5. Over here, the combination, or how many different ways that term could occur, is the total power. And then these two powers that we just wrote is the quick way of finding that combination, right? And then throw in the details. The first term is 2x cubed. And the second term is negative y. All right, now it's cleanup time. So let's start with the coefficients. I'm going to need more room here. All right. So for the coefficients, if I have 12 times 11 times 10 times 9 times 8 times 7 factorial over 5, 4, 3, 2, 1, 7 factorial. The 7 factorials drop out. And let's talk some canceling here. So 4 and 3, that cancels out of 12. And the 5 and 2, that cancels out of 10. And so I get 9 times 8 times 11, 72 times 11. This is actually where I made my mistake, 792. That's this guy. This is 792. All right. Now I also have the 2 to the 5th, which is 32 to handle. X cubed to the 5th. Do I add those exponents or multiply them? So the question is, do I go x to the 8th or x to the 15th? And if you're ever confused, you could always say, well, x cubed to the 5th means I have 5x3s, x cubes, and altogether that's x to the 15th. So the short answer is you multiply them. Now the negative y to the 7th, first of all, the negative to the 7th implies I'm going to have a negative answer because it's an odd power. I would have 7 negatives there if I wrote it all out, and that's odd, or that's negative, and y to the 7th. All right, and now here's where we eye roll and say, okay, it says no calculator, so I guess we have to multiply by 792 by 32. And again, if you made a calculation error, then I'm with you. I made the same. I had a mistake on my key when I multiplied there. I guess I'm a little... If you recall, we had a factorial expression, and we are at 792 for the factorial expression, 32x to the 15th, negative y to the 7th, and we're multiplying 729 by 32. 792 by 32. So, and I believe I messed that up. And so let's get this right this time. 4, 8, 1, 15. That seems right. And 6, 7. That seems right. So 4, 4, 1, 13, 1, 5, and 2. So 25,344 x to the 15th. It was a negative y to the 7th. All right, maybe you made the same mistake I did, which is a multiplication error. Okay, so most people did this well. Let's talk about, first of all, what do I divide by, and then how do I express my answer? So remember, you divide by the 0 of the divisor. So the 0 of x minus 2 is 2. The coefficients are 1, negative 5, 0, and 12. No placeholders, or sorry, 1 and 12. 1 and 12. Cube, square, first degree. Okay, so we're good there. So we bring down the first number, multiply. Bring down the first number, multiply, and record it in the next column. Multiply and record it in the next column. Add there, multiply, and record it in the next column. And so we get 2. Now, the quotient, there's all these different kind of answers here. The quotient is what's the answer to the division problem. So when I took x into x cubed, the power then is x squared. So the results here tell me my answer is x squared minus 3x minus 5. And then this is the remainder plus 2 over the divisor x minus 2. All right. 7, use the remainder theorem to determine if 2 is a 0. Some of you, I wasn't crazy about how you worded your conclusion, so let's talk about what that should look like. If I divide 2 into 1, negative 2, 0x squared, 5x's and negative 10, then bring down, multiply, add, multiply, add, multiply, add, multiply, add. Because the remainder equals 0, 2 is a 0 to the equation, right? That's what you should look like, is you should make reference to what the remainder theorem is, which is to say the remainder tells you if it went in evenly or not. Okay. With all identities, you can do them a lot of different ways. So this is one way. It doesn't have to be this way. If you want to stick with how you did it, but find your own mistake, that's fine. But if not, you can start from scratch. So I'm going to factor, or I'm going to replace sine squared with 1 minus cosine squared up top. All right. That factors into 1 plus cosine, 1 minus cosine, and 1 minus cosine divides away. Yeah? So now I have 1 plus cosine on the left-hand side. I want to get secants. Well, let's talk about that. I could multiply in fractions. So it came to me, why don't I just divide or multiply by secant over secant? When I do, I get secant x plus secant x cosine of x over secant of x. Oh, man. Okay. Sorry, my internet keeps dropping. All right, so when I multiply top and bottom by secant, the top is fine, it's secant, and then secant is 1 over cosine. So the cosines divide away, and I get secant plus 1 over secant, which is what I was aiming for. Okay. All right. On 9, a lot of people had the right ideas, but they made a small mistake here and there. Maybe the y-intercept was an issue. So let's start off with the overall shape. I have a negative, and I have x to the first, and x squared. So I have negative x to the fourth. That means that my work should go down and down. As x gets infinitely large, I'd get a huge negative number for both positives and negatives if there's a negative out front. So if I get negative y's, the graph will go down, not up, down. So I know the graph will do that on the outside. Jeez, not up, dummy. Go down on the outsides. Now let's go to the zeros. I had a 0 at x equal 1. If x equals 1, y would be 0. If x equals negative 4, y would be 0. And if x equals 3, y would be 0. And then the last thing is there's that square. Remember, when there's a square, then the graph doesn't pass through the axis at that point because squares don't change signs on either side. Remember, negative squared and positive squared behave the same sign-wise. So anything that's squared, the graph will just bump off that point rather than pass through the axis. So let's start at the left. I'm starting at the low. It's going to pass through. Now, before I get to those zeros, I guess I need the y-intercept. How do I find the y-intercept? Well, remember, at the y-axis, you know that x equals 0. Y could be lots of things, but x has to be 0. So if you put in an x of 0 into the equation, you get negative 2 times negative 1 times 4 times negative 3 squared. So the y-intercept should be something like 2 times 4 times 9, or 8 times 9, or 72. So the y-intercept is going to cross way high at 72. Then what's it going to do? Well, again, at the 1, it's not even powered, so it's going to pass through that 0. It's got to come up and hit the axis here. And this, though, it's going to bounce off because of the square and head back down. And so that's what the graph should look like, right? With the y-intercept of 72. Okay. For 10, you're looking to make the summation notation to this, so you really need to figure out two things. What's the equation for the pattern, and what's the last and in? Well, the pattern, you need to look at it. You're adding 4, so it's arithmetic. So the pattern is like the idea of saying, I'm going to start at some first term and add over and over again so many times. The first term is 3, and I'm adding 4 some number of times. And that checks out as far as when n equals 1 goes in. We'd get 3 plus 4 times 0, which is 3, so that's working. When n equals 2 goes in, we get 3 plus 4 times 2 minus 1, which is 7. It seems to work. Now the only question then is, what's the n that makes that last term? 3 plus 4 times what n would make 311. So if you subtract the 3, divide by the 4, let's see, what do you got there? 77, and add 1, then that means the last n must have been 78. That's how you do that, right? Same deal here, analyze the pattern, except this time it's not an adding pattern, it's a multiplying pattern, which is geometric. So we know that in geometric, you can make terms by taking a first term and multiplying by some common ratio every time. So in this case, A1 is 3. And what are we multiplying by each time? I hope you said negative 2. Always verify, especially on a test, but anytime, just make sure, does that rule work? Does that make 3 when the first n goes in? Does it make negative 6 when the next n goes in? I think you'll say that it does. As far as what's the last n in now we need to figure out? Well, if negative 24 comes from starting with 3 and multiplying by negative 2 so many times, I divide by 3, then I'm getting something like this. Now, I just did this by kind of just guess and check. I know the power needs to be 3. So n minus 1 needs to be 3. So n is 4. Oops. The problem is that I didn't see that it doesn't have an endpoint, so I'm dumb. So actually, there's not a lot of thinking involved there. It's infinitely long, so never mind. Sorry about that. I was thinking it ended at 24. I didn't read carefully. All right. But I make my mistakes, but I catch them usually before I finish it up. So, all right. Last but not least on this page, 12. All right, so we need to simplify this, what can we do? Well, I can't multiply x plus 3 times 6. That's ridiculous. But this, that surely can be simplified by log rules. So if you simplify by log rules, then you could put x squared plus 5x plus 6 over x squared minus 9. Then it's 6 to the log. Those are inverses, they cancel. So you have x plus 3. And then this expression, in order to simplify further, I'm going to factor it. Now, some people made factoring errors, and that's understandable. That top one is one of the great Algebra 1 gotcha factors because you have to pay attention to the signs. 6 can factor into two ways that make a 5, 6 and 1 or 3 and 2. But if it's going to be positives everywhere, it has to be x plus 3 and x plus 2, not 6 and negative 1. And the bottom is difference of squares. So you get something like an x plus 3 dropping out. Oh goodness, sorry. I didn't see that that was a negative. So this is negative 5x. So darn it, these should be x minus 3 and x minus 2. So x plus 3's drop out, x minus 3's drop out, and all you're left with is the x minus 2. Sorry about that. My eyes are kind of having a hard time with the screen size. All right, so here we go. Last but not least, the last page. Thank you for sticking with me. We're almost done, and this is your only homework, so that's not bad. Okay, for 13, you have to realize what's part of the pattern and what's not. The 4 is not part of the repeating pattern. So when you go to figure out your A1 and your common ratio, the 4 should not be part of the calculation. So this is geometric. You're going to do A1 over 1 minus R and then add the 4 later. So 4 plus the A1 is 0.13. The common ratio is, you're repeating 2 digits, so that means you're shifting over 2 decimal places, which happens when you divide by 100. So the common ratio is 100th if we think of what we're multiplying by. That's 4 plus 13 over 99. That's 4 and 13/99, which I wanted to leave, but unfortunately the question says an improper fraction, so we have to multiply. Depends on how you multiply 4 by 99, but I think of it as 4 times 100, take away 1 4. So that's 400, take away a fourth, that's 396. And then I add the 13 on. So that's something like 409 out of 99. Alrighty. I don't think that reduces because 3 and 11 are the factors of 99. And those do not go into 409, so we're good. All right. 14, you had to have your identities at hand. Probably because this is sine, you want to use the one form of this that's sine only. So that's 1 minus 2 sine squared minus sine of x equals 0. If I get everything on one side so that it's a positive, I get 2 sine squared plus sine minus 1. That does factor. So that's 2 sine and sine and 1. To make a positive sign, this would have to be a positive 2 and a negative 1 on the OI and FOIL. That means that sine has to either be positive 1/2 for the first factor to be 0 or negative 1 for the second factor to be 0. Sine is 1 over 6, so 1 over 2 when the opposite is small and positive. So those are pi over 6's in the first and second quadrant. That's 5 pi over 6 and pi over 6. And sine is negative 1 at the negative y-axis, so that's 3 pi over 2. All right. simplified log by log rules. So most people made the same mistake here and they didn't factor. The combining was fine. So if you move the 2 up, put those together by multiplication, and that you call division because it's subtracted, then it would be something like log of z squared times x minus 1 all over x squared z minus y squared z. So if you lost points here, it might have been because you didn't finish, you didn't simplify completely. Oops, I went calculus all of a sudden, sorry. All right, so the log of, let's say we factor, then the top is pretty much clean, but the bottom, I could take out a common factor of z, and when I had x squared minus y squared, that also factors by difference of squares into x plus y, x minus y. So that if I divide out a z, divide out an x minus y, my final simplified answer is log of z over x plus y. All right, that's as simplified as you can get into a single logarithm. All right, for 16, standard form means we're going to factor so we can find the center and the foci. So if we take a 9 out of the 2x terms, then we're going to have x squared plus 6x, leave a space to complete the square. Let's take a 4 out of the 2y terms, leaving me with y squared minus 2y, leave a space. We're going to move the 49 over so it's negative now. And here we go, completing the square. What goes there is half of this coefficient, which is 3 squared, which is 9. But I really, if I distribute it out there, in terms of what would be different, I would see an 81 that had been added. So it's plus 81 to balance the equation. Likewise here, half of negative 2 is negative 1, but squared is positive 1. But if I distributed, I really just added a 1 times 4 or 4 to balance them. So I have 9 times x plus 3 squared plus 4 times y minus 1 squared equals, and over there, what I got there, I have 36, yeah? All right, so now, dividing by 36, I get x plus 3 squared over 4 plus y minus 1 squared over 9 equals 1. From there, we can see the center is the opposite, so negative 3 and positive 1. The foci will come back to the major axis length. If I went left 2 and right 2 and up 3 and down 3, then you could see the major axis length would be 2 times the larger square root, which would be 2 times 3 or 6, all right? It's vertical. Now, remember that in terms of finding the c, or the distance to the foci, c in ellipses is the square root of the difference between the two, not the sum. So it's 9 minus 4 square rooted, or 5. Now the question is, which way do we go root 5? And it's on the major axis. So as far as what will stay the same, what will be different, the x will stay the same. And from the y of negative 1, we're going to add 5 and subtract root 5, sorry. So it's negative 1 plus or minus root 5 for the foci. All right. Last but not least. Okay, so hopefully you found the center. Fine, it was right there. So 1, negative 3. and that the radius is 2. So when you say x minus the center, x minus 1 squared plus y minus negative 3, so plus 3 squared equals the radius squared, so equals 4, yeah? General form then means everything on one side. So if you FOIL this out, put everything on one side and simplify, then it would be something like x squared minus 2x plus 1 plus y squared plus 6y plus 9. Move the 4 over, so it's a negative 4. And general form then is the squares first, so x squared and y squared. Then the normal x's and y's, so negative 2x and 6y. And then the total of all the constants. So we have 1 plus 9 is 10, subtract 4 is 6, equal to 0. That's it. All right, so give me your corrections to me by the end of the day in Google Classroom, and I appreciate you watching. This is your homework for the day. It's due tomorrow by 3 o'clock, and I hope you have a great day.